Thank you.
Thank you, Engineer Dr. Sai Jones. Give us a informative and fruitful talk about how to use waste to generate the hydrogens for some of the applications. So now we move on to next topic, and let me introduce our next speaker, Engineer Jason Fan. Engineer Jason Fan is a professional engineer as a fellow member of HKIE. He is currently the chairman of the Gas and Energy Divisions of Hong Kong Institute of Engineers. With over 30 years of experience in gas and energy sector, he also was the former director at CLP Powers and the deputy general managers of CLP Energy Infrastructures. He also delivered lectures to some of the academic institutions and organizations. Ladies and gentlemen, please welcome our next speaker, Engineer Jason Fan.
Thank you, everyone. Good afternoon. I think the topic that I'm going to present is different from the brochure. In the brochure, you will see that the hydrogen storage in Hong Kong, right, for transportation. But actually, I don't see too much storage in Hong Kong for transportation, frankly speaking. Anyway, so I think what I want to present is bring everyone back one step. Why hydrogen? I think that's the key. We talk about a lot of hydrogen technology, hydrogen development, but why? We have been using fossil fuel for many years. We have been changing from coal fuel to natural gas. For example, power generation now, you can see over 50% is using natural gas. We are happy with natural gas so far, but why we think about hydrogen? I remember around 20, 30 years ago, we looked at the reserve, the global reserve of the fossil fuel. Natural gas, I remember those figures like 60 years, so we can use natural gas for 60 years before the reserve completely being used out, which was 30 years ago. I looked at the data last year, it said 143 years. We have quite a lot of natural gas actually, so why? I think that's very important questions that we need to ask ourselves. We pay a lot of money to invest in hydrogen, why? So without this commercial reason, it's difficult to justify us to do a lot of things, okay? The very important one is from the COP21 actually, the Paris Agreement. Because we know that the global warming is coming actually, so they want to control it, right? Okay, but somebody's still saying, is that true? Some environmentalists may be cheating us to gain money or whatever reasons. Is that true? Then as an engineer, as a humble engineer, we need to look at the data. We need to look at whether it's true or not, okay, before we confirm it. Okay, look at the data here. This is the data actually, 1950 to last year. Obviously, the temperature is growing, okay? You cannot ignore it. So it is a long average out figure. It's true, right? Okay, there's nobody make it up, okay? So in the last 10 years especially, you can see the rising of temperature is significantly increasing. So we have to do something. Okay, we continue to look at the temperature rise. Actually, remember what they said is 1.5 degrees Celsius to control that the increment. Okay, not more than that, but actually, if you look at the figure, in the last 50 years, it already grew by 1 degree Celsius. And last year, or you can say 2023 to 2024, already increased by 0.4. So we are already 1.5. Of course, you will be up and down, okay? You will up and down a bit about that, but hopefully it will come back a little bit. But I just want to give you a message that it's really coming. It's true. It's not some environmentalists cheating us, okay? And then look at the Antarctic winter sea ice extends. Okay, this is very important figures for the environmentalists actually. Why? Because the ice surface help to reflect the sun so that the global warming, the heat will not be absorbed by the sea. If the area of the ice has been reduced, a lot of heat will be absorbed by the sea. So it increases further about the global warming. I think that's a very important indications. So look at the last 2 years, okay? The last year one is the lowest one actually already, the second lowest one. And 2023 is the lowest sea ice areas, okay? So I just want to tell you, do you believe it now? Okay, so you believe. If you believe it, then I still have another question. Then why hydrogen? We have renewable energy. Okay, why we need hydrogen? We need to spend a lot of money to develop that, okay? Okay, look at the renewable energy I want to explain. Of course, someone saying that the hydro is not renewable energy, but anyway, it is something from the earth, from the natural earth, okay? So we have a lot of hydropower, I would say in China, of course. But you look at the locations of this hydropower, it's more in Sichuan province, okay? They locate in certain area. It's not being everywhere you have hydropower. You more concentrate on certain. And you look at actually, in China, we have developed a lot of hydropower. I think you may have heard the news about they are doing a new project in Tibet, which is 3 times the size of Gore Dam hydropower, which roughly 8,700 megawatt size, something like that, I think. So it is besides the India. So India people keep fighting objection because you are in the upstream of it. So in any case, anything happen, you will impact India. But anyway, China will do it. Anyway, so we have a lot of hydropower actually, just the location-wise. And what about solar? We have a lot of solar. I've been to Inga Mongolian, I've been to Tibet. Well, we do have a lot of solar power actually there, right? So if you look at this, actually, one more information is, I don't know whether you heard about this. Actually, the energy from the sun to reach the earth in 1 hour, you can meet the world's need for an entire year. We have a lot of solar power. Depends on how much you can absorb, you can use it, utilize it. And that's the key. You can utilize all the solar. We have sufficient, right? Then, okay, how about the wind? The wind power in China, I think Mr. Lee already described a little about the wind power. You go ahead. I remember around 2010, CLP Power, when I was working in CLP Power, okay, they developed a wind farm project. We talk about 3 megawatt, 5 megawatt is a major, very big, very huge wind turbine. But now we talk about 22. So it's 7 times how big the size is. So we even developed this kind of twin turbine and floating. You don't need to drilling, you don't need to piling, no need, it's just floating on the sea. So you can see this has been developed quite good in renewable energy. But the problem is where? You can see the band there, circled in regular, which is where you can utilize the wind, because that is a limitation. You see the 4 meters per second wind speed is somewhere you can absorb the heat and utilize it more effectively. But actually, when I visiting there, they say 2 meters per second is okay now. So you see the technology is developing. But still, the problem is you still have certain area with wind. I remember when Hong Kong was developing the wind farm project, it was now rejected by the government, okay? The reason is still is too high, okay? Because the cost is too high. So it's not justified for Hong Kong to do it, although it's much better than 10 years ago because of the larger turbine blade, those kind of things. But still, higher than natural gas, higher than those kind of things. So why not we just buy the renewable power from China. Okay, so where is the demand? I think you know that it's around the eastern part of China, okay? We use in Hong Kong, we use a lot of power, but not in Tibet, not in Inner Mongolia. So that's the problem. We have a problem of the area, okay? We have a lot of power, actually, renewable power, but the area is an issue. Besides the location, the timing is another things that we need to be aware of. I tried to use the case in Germany. I think Germany is a very interesting country that we may worth to look at it. So in 2012, you can look at the pattern of the fuel being used for power generations, okay? The bottom is nuclear, just like Hong Kong, okay? You see Hong Kong now, we have around, if you see the whole Hong Kong wise, okay, not just CLP or Hong Kong Electric, the whole Hong Kong wise is 25% nuclear. The nuclear power, you have to keep it stable. You can't go to shifting up and down, no. You have to be very stable, except you can shut down during the change of the fuel, those kind of things. So it has to be at the bottom, okay? And then you have coal, natural gas, those kind of fossil fuel as the second one, okay, second layer. And at the top, the renewable energy, right? Because the renewable energy is not something you can control. They gave you, then you have it. If no sun, then no solar energy, okay? No wind energy. So that's always at the top. But now, because we have been building so many renewable energy generators, look at the 2020 in Germany, because Germany is the first country, I think, in Europe to get rid of the nuclear, because unsafe, right? I don't know if you remember that. So no nuclear now. They use all traditional energy for two shifting as a buffer for those renewable energy. So they face a lot of problem with the reliability, because if you rely too much on renewable energy, your power system will not be very reliable. You're taking the risk of your power supplying grid system, right? So my suggestion, or it looks like we can do it with hydrogen, is we have nuclear, like Hong Kong, I believe. I think many people, or the power company are already saying, even in China, they're saying nuclear have to be one of the main power supply source to achieve the 2050 carbon neutrality target, or in Hong Kong it's 2050, but in China it's 2000, or mainland China I should say, 2060. So if you still have nuclear, then you become less flexibility again, because you can't change, right? You can't do two shifting. Then you still have some power that you can generate is hydrogen, because you can't use natural gas. I'm sorry, because you are net zero carbon. Natural gas still have carbon generation. So you can use hydrogen, but at the top, you have to use the maximum of what you can obtain from the renewable energy. But since you have so many renewable energy, so many solar power, hopefully in Hong Kong, then it can be drop down to the area that you already have nuclear power. Then what can you do with that? You can't shut down the nuclear power. So hydrogen is the buffer here. You use the surplus of renewable energy to generate hydrogen. And the hydrogen as a storage, when you need to use it, then you can use it, right? So this becomes a very reliable, a very environmental friendly power generation pattern. That's what I think maybe Hong Kong around 2050 will look like, okay? Okay, we already, I hope right now you're convinced that, okay, why we use hydrogen. So when you believe it, then I can start talking about, okay, what we should do, okay? From production, storage. I was just talking very briefly because I think all the experts here already talk a lot about that. I just talk a very high level one, assuming a layman, okay? Even you don't know hydrogen, but I hope you will understand this, okay? So we basically have 3 or 4 four process for the whole process, okay? Production, storage, and transportation, or you can storage plus transportation, and then the application you use it, okay? So I try to mention about that. So at this moment, I would say we only have 1% green hydrogen. Assume you know what is meant by green hydrogen, okay? Hydrogen got a lot of color. You have green, you have blue, you have gray, you have pink hydrogen. So when I talk about you can use nuclear to generate hydrogen, which is pink hydrogen, we say that. So anyway, but for green hydrogen now in the world, actually we only have 1%. So a lot of hydrogen being generated from natural gas, actually. Of course, we have tank gas also generating hydrogen, but actually tank gas, I was working in tank gas for 8 years, actually. They use naphtha to generate tank gas, and when they have natural gas, they convert natural gas to tank gas, so we have 50% hydrogen, right? But that's still the minority in the world, in the global world. The majority of that is still natural gas. Of course, we still have some oil field, coal, those kind of things. And there are a lot of processes we can do that. They are still developing different processes. Steam methane reformer is the key to transform from heavy hydrocarbon to hydrogen, okay? But I don't want to talk in the detail, but that's still, I just want to give you a picture about how much green hydrogen we have nowadays, actually. Okay, so we also have mainly 3 methods. Actually, we have Cedric here. I remember Cedric from Lindy. Their company produced or provide the hydrogen in Hong Kong. So one type is SOECs. They need the high temperature to do that. And so normally we say that we will only use this method when we have waste heat, like nuclear plant, those kind of things. PEM, actually, I think you will see some other lecturers been talk about, speakers been talk about this. Actually, this one becomes more and more popular. PEM is more expensive than AEC, the one below. More expensive because they use the more precious material, so it's more expensive, but they are more flexible. Why I say that is actually for PEM, we use a lot of renewable energy, right? The renewable energy go ups and down. We have wind, we have sun, then we have energy. If we don't, so then PEM can adopt these fluctuations of the power supply and still can produce hydrogen. So PEM is getting more and more popular, although more expensive. So it depends on the scale of production you have. PEM is going more and more popular. But now, so still the most popular is AEC, which is the alkaline type, which is much cheaper because they use cheaper material. So obviously they are low in price. This is just, I want to show you that why we use PEM, because it can absorb the fluctuation of power. Okay, then storage and transportation. We can gas, liquid, solid, right? Just a simple explanations about it is for gas, actually because we can take reference to natural gas. I don't know whether you remember, if you go back 20 years, some years ago, okay, we transport gas by pipeline. If you want to do a lot of gas transportations, actually, pipeline is one of the way, a gas state, okay, liquid is another story, okay, at gas state. So that's why around year 2000, mainland China start to build west to east gas pipeline 1, west to east pipeline 2, and then develop the whole, actually the natural gas pipeline system only developed for 20 years in mainland China. In the last 20 years, actually they have built significantly, and also tank gas has been invested in China for domestic supply, which is also the last 20 years, actually. When I'm working in tank gas, they have not started investing in PLC. But now they have really invested in PLC. You can see the development of mainland China is quite significant. And pipeline actually is very important if you want to use a lot of hydrogen. You need to develop a hydrogen pipeline, which is quite important, okay? Because in, sometimes we say within a few thousand kilometers scale that actually pipeline is very effective and very good. Yeah, and of course the cost. We talk about cost in developing. If you have using the mobile truck to deliver the compressed hydrogen, it's very expensive actually. Yeah. So when you have a lot of hydrogen usage, you have to use pipeline. I think that's the story. So how long is the hydrogen pipeline? So based on some statistic information, so far, the United States has got the longest pipelines here, but China is coming actually. I will show you later. In Europe, they also have like 1,600 kilometers of hydrogen pipeline. Okay. The material, because the cost is very important, they now developing a fiber reinforced polymer, because this kind of instead of using the stainless steel or carbon steel, this kind of material, you can have a length of like 1 kilometer long. So the weld joint will be less. When you're building a pipeline like the west to east, like 4,000 kilometers, you think about how many pipelines you need to join, how many joints you will have. So this will save like 20% of the cost. Another philosophy is saying that, okay, maybe we should not build another hydrogen pipeline. Maybe we can use the existing natural gas pipeline and try to mix with certain amount of hydrogen. So we can still do some in a transient period at least. So we can still be more environmental friendly, right? So as a statistic saying, like 15% hydrogen has no problem. Hydrogen, the cetane gas got 50%, so should not be a big problem actually. A lot of pipeline in Hong Kong, I think that the time is coming up, so I will be quick. In China, they having a lot. I would say you will see it's coming in China. I want to show you one thing is this one. This is the Inner Mongolian pipeline. Which I found recently, they're just showing in the website, is they have a philosophy of one main pipe, and then two circles, and one green ammonia. So this is the latest one I heard about this. So they are building the network now, it's coming. Liquid, I think I see another topic, we'll talk about the hydrogen, liquid hydrogen in detail, so I will not talk about it in detail. Liquid hydrogen is also another way I can see coming, just like natural gas actually. You have liquefied natural gas in the later part when you want to transport longer distance, and liquid is another way. Obviously, Japan is the one who have the first liquid hydrogen vehicle, Whistle, and another one is coming, I heard about that, but very expensive so far really. So this is the solid hydrogen. I think I would just demonstrate, I remember Mr. Lee have that, I don't know whether I can do that here, let me see. Yeah, I will show you the video, because you heard about that, right? I don't know, have you seen it? I will demonstrate it, I think I finished my presentation at this here. So this is, where is the solid hydrogen, okay? You can see just like a pack, which has been vacuumed, and then they take it out and put it in a container. Very simple to transport. So the solid hydrogen is something like that, okay? I think this video is more convincing when you look at it more than the theory. So you pour the water, okay? You put the water inside, and that's it. The water quality is not important, actually. I heard about that. You even seawater, you can also put in it. Okay, that's what I heard. Okay. Very quick. I finish this. I will finish the presentation. Okay. And then you will see some vapor come out very quickly. Okay. And then, let me see if we can the later part. Wait. Okay, they connect it to a fan, electric fan, then they move it. They can move it. Okay. So I just want to demonstrate that's so simple, right? And at atmospheric pressure, atmospheric temperature, and nothing else. So I think I'll finish here. I don't have too much left actually in this presentation, but I hope give you some idea about this hydrogen. Okay. Thank you.
Thank you, Engineer Jason Fan. Thank you so much for giving it a